Hello all, this is lecture 2 of Electrical Machines lecture series, which is a part of basic electrical engineering course. In the last lecture, we have gone through introduction of machine and electrical machine, types of electrical machine, single phase supply and three phase supply. In this lecture, we'll go through types of motor and then construction of three phase induction motor. This hierarchical diagram shows the basic types of motor. We know that in case of motor, we need electrical energy from the input side, and so depending on the type of electrical input, motor can be of two types: DC motor, which needs DC supply, and then AC motor, which needs AC supply. Again, this DC motor can be of two types: brushless DC motor or brush DC motor. Brush DC motor is of two types: separately excited and self-excited. If it is self-excited type, then it could be of series or shunt or compound or permanent magnet type DC motor. Similarly, AC motor is of two types, synchronous and asynchronous. Asynchronous AC motor is also known as induction motor, and depending on the AC supply, it could be of single phase induction motor or three phase induction motor. This is very basic types which has been shown here. Apart from this, we can have several different types. Whenever it is required, we'll quote. One example is universal motor. As its name indicates, it can work with both DC and AC supply, and that's why it is called universal motor. Now, as per the syllabus, we'll go through construction of three-phase induction motor. Three-phase induction motor, as its name indicates, needs three-phase AC supply and produce mechanical rotation. It has a number of applications like accelerator, mills in industries, etc. It has three major parts: a stator, rotor, and end wells. Out of the three main parts, two are the major parts. In fact, we can say that for all the motor, we have two major parts, stator and rotor. So one by one, we'll go through these parts. We'll start with stator. Stator, as its name indicates, is a stationary part of the motor. It doesn't rotate. It has three sub parts: stator core, conducting wire, and frame. This is core. On the core, there are slots, and within the slot, stator coil are placed, which is made up of copper or conducting wire, and this outer body is frame. So this stator core is high-grade alloy steel slotted on the inner periphery, and it is made up of thin elements which are insulated and then laminated together to manufacture the stator core, just to reduce eddy current losses, what we have seen in case of transformer. This conducting wire is basically the copper wire used to form the stator coil. The coil placed at the slots of stator core is known as a stator coil, and we have to give three-phase supply to these coils. Then the last part of this stator is frame, made up of cast or fabricated iron, consists of cooling fins. These fins are used to dissipate heat generated within the motor, so that temperature of the motor will be within the working range, and so motor will work correctly. Whenever motor runs, it dissipates some power, which is basically the losses that happens within the motor, and so that heat must be dissipated. So outer surface uh, is doing this task. With the help of cooling fins, we are basically increasing the surface area so that the cooling will happen faster without increasing the diameter of the motor. It also supports and protects other part of the motor. Now the second major part of motor is rotor. Like its name indicates, it is rotating part of the motor. It has three subparts: rotor core, conducting rods or coils, and then end rings or slip rings. It depends on what kind of rotor is. So we are going to use conducting rods with end rings or coil with slip rings. Basically, rotor is of two types: a squirrel cage rotor and cage wound or slip ring rotor. This squirrel cage rotor or feed wound rotor has core, which is known as rotor core, built from a high-grade alloy steel lamination slot on the outer periphery, and within the slot either rod is placed or coil is placed. If rod is placed with end rings, then it is known as a squirrel cage rotor. If coil is placed and those coils are connected with the external resistance with the help of slip rings, then it is known as slip ring rotor. This squirrel cage rotor has its name due to its shape like a squirrel cage, because if after placing the conducting rod, if we remove the core, then it looks like a squirrel cage, and so it is having its name, a squirrel cage rotor. Mostly, a squirrel cage rotor is used because of its various advantages. In the next lecture, we are going to see the difference between a squirrel cage rotor and cage wound rotor. Conducting rod, it is made up of copper, aluminum or alloy, used as a rotor winding in case of a squirrel cage rotor. And this rod must be insulated, must be short circuited at the ends, and so end rings are used, which is made up of copper, aluminum or alloy rings used to short circuit all the winding rods on the core. End well made up of same material as that of frame used to protect the motor for the two sides. So as a summary, we can say that motor has three parts: stator, rotor and end wells. Stator has stator core, and on the core, coils are placed within the slot of the core, and three-phase supply is connected to the coils on stator. And within the vacant area of this stator, rotor is placed, which is again having core, conducting rods or coil, end rings in case of a squirrel cage rotor, or slip rings in case of slip ring rotor, and then we have end wells, and finally we have three-phase induction motor. All the pictures which I have shown within this lecture has been taken from this very good animated video. You can find similar videos on YouTube. A number of videos are available, and this is the reference for this lecture. So let's see this video.
Explain the construction of a three-phase induction motor. A three-phase induction motor is used in escalators, paper industries, etc. Let's understand how it is constructed, but first let us take a look at its elements. A three-phase induction motor consists of a stator, a rotor, and two end bells, where stator and rotor are its main parts. Now let's describe each of these elements. Stator is the stationary part of a motor, and it consists of a core, a conducting wire, and a frame, where the stator core is made up of high-grade alloy steel rings, which are slotted on the inner periphery. These rings are insulated from each other and then laminated to form the core. Conducting wire is made up of copper wire and is used to form the stator coil. And frame is made up of close-grained alloy cast or fabricated iron. Its outer surface consists of the cooling fins. In order to increase the heat dissipating area without increasing the overall diameter, it gives support and protection to the other parts of the motor. Rotor is the rotating part of a motor, and it consists of a core, the conducting rods, and two end rings, where the rotor core is a cylindrical core built from high-grade alloy steel laminations with parallel slots on the outer periphery. If the slots are not parallel to the shaft of the core, then the rotor is called a squirrel cage rotor. And if the slots are parallel to the shaft of the core, then the rotor is called a phase-wound or slip ring rotor. Note that mostly squirrel cage rotor is used because of its various advantages over the phase-wound rotor. Conducting rods are heavy bars made of copper, aluminum or alloys and are used as a rotor winding. And the end rings are made up of copper, aluminum or alloy rings and are used to short circuit all the winding rods on the core. And the end bells are made of the same material as that of the frame. It is also used to protect the motor for the two sides. Now let's construct a three-phase induction motor using these elements. First, wound all the conducting wires on the stator core, all around it, to form three different parts of the coil that behave as three-phase winding. Then attach four outlet wires to these three parts of the coil to connect them to a three-phase supply. Then place this stator core inside the frame to form a stator of the induction motor. Now insert the conducting rods in each slot of the motor core. Then weld the end rings on both sides of the rotor core to short circuit all the winding rods on the core. This forms the rotor of the induction motor. Now place this rotor inside the stator carefully and then finally attach the two end bells to it to form a three-phase induction motor. Thus we have constructed a three-phase induction motor.
So this is the end of this lecture. In the next lecture, we'll go through a squirrel cage rotor versus phase wound rotor, which is also known as slipping rotor. Thank you.